What's up, y'all? This is section 3.1, the start of chapter 3. We're doing solve linear systems by graphing. What is a system exactly? I'll tell you right now, a system is just a collection of equations that you have to consider at the same time. And so here, oftentimes, at the very beginning when we're talking about systems, it's going to be two equations and two unknowns. And you have to figure out what x and y are going to be. They're some pair of numbers, x and y, are going to satisfy both of these at the same time. And so the way you figure out what x and y are going to have to be is, we have a couple different methods, but the first one here is graphing. So let me show you what that looks like. So solve the system and estimate a solution. We're going to do this by graphing. And actually, as we go through, you'll see the different packets. We've got like different techniques, at least three. So the first one is graphing. Let's graph this one. 4x plus y is equal to 8. You know what? I think what I'm going to do is rearrange this equation just a little bit, mostly because I see that x and y are next to each other on the same side of the equation. I'm just going to subtract 4x from both sides, like this. And if you subtract 4x from both sides, then you get something you can very easily make a 0, 1, 2 table out of. So I'm going to go, the x values are going to be 0, 1, and 2. And then I'm just going to put them in. And you can see here, when x is 0, it becomes 8 minus 4 times 0, which is just 8. 4 times 1 is 4, so 8 minus 4 is 4. And 4 times 2 is 8, and 8 minus 8 is 0. So doing the multiplication and then the subtraction, you get these numbers. I'm going to do the same thing over here. Actually, a slightly different thing. I'm noticing that there's a 3 right here, and I think solving for y might be a little trickier. So I'm going to just choose to do a different kind of table, a 0, 0 table, where it'll tell me the intercepts. So no need to rewrite the equation for this. I'm just going to do two rows. First, I'm going to let x equal 0, and then if x is 0, I'm going to calculate what y is going to be. So I plug it in. 2 times 0 is just nothing. It's 0. You don't even have to write it. The whole thing becomes negative 3y equals 18. Dividing both sides by negative 3, you get y is equal to negative 6. So that's the first point that we can plot over there. The second one is, instead of going 0, 1, 2 like I did over here, I'm going to put 0 in x and 0 now in for y. And I'm going to do the same thing, basically. I'm going to put 0 in for y and the equation, and it becomes 2x minus 3 times 0, which is just 0. So 2x equals 18. Dividing both sides by 2, you get x is equal to 9. So now I've got something I can plot. So let's do the red one first. I'm plotting the points 0, 8, which is up here, 1, 4, 2, 0. Then, and I'm going to do it very carefully because artistry actually really does matter here. You can't just like sketch it out. What I'm going to do next is I'm going to plot 0, negative 6 down here, and 9, 0. I know graphing with all these zeros is a little tricky, but to stay organized and remember which one is x and y. Anyway, here's the red equation and the red line, and here's the blue equation and the blue line. And the answer is going to be where they intersect. And you kind of have to zoom in a little bit. That's why, I think if you're really going to do this like on pencil and paper, you should use a ruler. There it is. The black dot represents the solution to the equations. It's the one pair of numbers, 3, negative 4. It's like 3 units over and 4 units down. 3, negative 4 is the only pair of numbers that's going to work in both equations at the same time. And in order to check that, you have to actually plug them in. So let's check the solution in the equations. First of all, the top one, maybe I should have made this red. In the red equation, put these numbers into the red equation, and yeah, it does actually work, because 12 plus negative 4 is equal to 8, simplifying. Let's check it in the blue equation. Put 3, negative 4 into the blue equation, and yeah, you can see it also works. So the answer is 3, negative 4, and we can report it like this, and then this is how we check the work. Now, there's a couple different cases. As we just saw, there's one solution, one dot, one intersection. And it occurs over here when the two lines intersect just once. Boom, that's the solution. There is a possibility that they actually don't intersect. If you got the two lines that are parallel, then there's no solution because there's no intersections. A third case might be an infinite number of solutions, where if the two equations graph the same line, they coincide. So actually, it's kind of difficult to see because the red line is underneath the blue line. It's possible that one equation gets graphed with two different equations, and if that's true, then it's going to have an infinite number of intersections and therefore an infinite number of solutions. There's an intersection at each and every single one of these points. That's the big idea. Solve the system, graph, and how many solutions? Okay, same thing, same instructions. All right, we're going to graph this thing. I think just looking at it, I don't want to try and solve this equation for y. That's going to be a couple steps that I don't want to do. I think I'd rather do a 0, 0 table. So I'm going to write down the equation, equation table graph. So here we go. Let's put 0 in for x first into the equation, and calculating what y is. What is 8 divided by negative 3? Well, if you want to figure out where it is on the graph, it's negative 2.6 repeating. So about negative 2.6. If you're looking to solve that equation and report the answer exactly, then maybe it's easiest to keep it in fraction form, like 8 over negative 3. But I think in this case, I'm just going to, in order to graph it and know where it is in the graph, I'm going to, because I'm producing a graph by hand, basically, I think the decimal is going to be a bit better for me and helpful to figure out where to plot it. Anyway, let's do the same thing in reverse direction. Let's let y equal 0 to figure out where the x-intercept is. Again, we plug 0 in for y, and it becomes, that whole term just disappears. It becomes 4x equals 8, which, as you can see, is 2. So we've got two different rows, and therefore two different points we can plot on the red line. Next one. I think I'm going to do the same thing. I'm going to do a 0, 0 table. 0 in for x. When we get that, we get negative 6y is equal to 16. Ooh, dividing both sides by negative 6, we get, again, negative 2.6 repeating. Plug 0 in for y, and we get this. 8x is equal to 16. It becomes 2. Wait a second, I think I see a pattern here. It's the same. I think that these two tables, two different equations, yielded the same points to plot: 0, negative 2.6 repeating, and 2, 0. So you can see on the graph, it's right there. Maybe it's. I tried to graph like two lines at the same time. The red one and the blue line. They're basically they're overlapping each other. They coincide. So you can say that there is. That there is an infinite number of solutions, as you can see there. Great. Let's do the next one. Solve the system graph. How many solutions? Here you can see x is, I think what I'm going to do is I'm just going to solve it for y. So I'm going to move this 2x to the other side, and therefore I can make a 0, 1, 2 table, which are nice and easy to do. You get 0, 1, 2, and then you put 0 in for x and calculate y. In this case, it's 4. 2 times 0 is 0. 4 minus 0 is 4. Do 1. 2 times 1 is 2, and 4 minus 2 is what's underneath the red dot, and you can calculate that if you want. Then the next one, we'll do the multiplication. 2 times 2 is 4. 4 minus 4 is 0 here. So we got 3 points we can plot. I'm going to do the same thing over here. Subtracting 2x from both sides, I get that, and I'll do a 0, 1, 2 table. Plugging 0 in for x, you get 1 minus 2 times 0, which is 1. And then 2 times 1 is 2, so 1 minus 2 is negative 1. 2 times 2 is 4. 1 minus 4 is negative 3. If you plot all the red dots and all the blue dots, red dots look like this: 0, 0, 4, 1, what's under the red dot, and 2, 0. Then you can also plot the blue ones here, and you notice 0, 1, 0, 1 hits here, 1, negative 1, 2, negative 3. They're parallel lines. Maybe we could have guessed that because they have the same slope with negative 2 and negative 2. Anyway, if they're parallel lines, then you know they're not going to intersect, and if there's no intersections, then there are no solutions. I wanted to drop in in the video that I've lived in Los Angeles for 9 years. It was a great time. I did living in California is wonderful. Have you ever been to Los Angeles or California, or where else have you lived? You let me know in class. Take care, and I'll see you in class.